Okay, welcome everyone. Yeah, I'm Sherwood Zern, and Paul Parkinson is also here with me. And we're not going to do an introduction other than to say that we both work for Oracle. And so we're going to go ahead and get started and jumping right into defining or talking about distributed transactions in microservices, and particularly with Helidon micro profile. Go ahead. Paul, next slide. So what we're going to first do is going to set some context. We just want to talk about why you would want to potentially switch to microservices, keeping in mind that microservices is not a silver bullet. It does provide you with some benefits, but in software, as in a lot of things, there's always trade-offs. And then we're going to talk about how you might want to migrate your existing monolith to a microservice. We're not going to spend a lot of time because that's obviously a whole session into itself, but we will talk about one particular pattern that is heavily used in that process. Then we're going to talk about some considerations about microservices, things to keep in mind. And then we're going to really get into the distributed transactions, and then Paul will go into how to do that with Helidon MP and how what you need to do, and then also he has a demo, so we'll go from there. Next slide. So let's first talk about why you may want to go to microservices. Keep it in mind that it doesn't necessarily mean that everything that is currently running in your enterprise today should go to microservices. There are some things that are well suited for the monolithic approach. There's definitely nothing wrong with that. But if you have things that you need to be looking at, number one is your change cycles. Is there parts of that application that change far more often than other parts of that application? When with the monolith, you can't just change that one particular piece and then just roll out that section. It's usually you change that, you roll everything back up into the monolith. You have to completely rebuild that monolith, test it, and then redeploy. With microservices, that's we can break it out through the bounded context and be able to just focus on that one particular piece that changes more frequently. And that way you're not having to redeploy, rebuild your entire application. And then you have the scaling aspect of microservices. Goes very closely hand in hand with the changing in cycles. And that is that, with the typical application server approach, if you needed to scale out, you just couldn't scale a web app or a particular EJB. What you ended up having to do is deploy that a whole new instance of that application server, which means, all the other components usually get redeployed with it just to keep it simple and also to keep optimization in your application. And then so you're actually consuming more hardware, more memory, storage, all those types of things when you're having to deal with the monolithic approach. So with the microservices, we can just scale out just those particular pieces that need to be scaled. And it's very easily, especially you're in a Kubernetes environment, to just say, hey, we need more instances of this service, scale it up from 3 to 6, and immediately scales for you, and then it can be scaled down. You can actually also have it set up some parameters in which you tell Kubernetes to scale automatically. And then you actually have, the ability to deploy independently and scale independently. The important part about microservices is to make sure you understand that firm bounded context. What should that service do? What should it be responsible for? And then you have that that luxury, or if you will, of once you have that piece, then that thing can scale independently of your other parts of that application. And then you have the polyglot when it comes to languages. You know, some languages are more suited for different types of processing and inside your application. So it's very easy then to build that part of the application in that language that is very well suited to satisfy that use case. It's not so easy to do if you're in a monolith. That monolith is the entire thing is usually written in one specific language. And then you have the ability, even though in monoliths, obviously not one team builds the entire thing. There is, you know, a whole set of teams building different parts of it. However, there has to be an extremely tight collaboration between those teams because it's all going to be rolled up together. And so you need to make sure that everybody is talking, and so that collaboration becomes far more important. With the microservices, yes, you still have that collaboration, but those teams can manage just that one part of their application, and they're not having, you know, this whole conglomerate a team that's having to manage the entire monolith. So next slide, Paul. So let's talk about, okay, so we decided that those criteria that we just talked about, it obviously makes sense that we want to take this monolith because we see it growing, it becomes unmanageable. Nobody wants to touch certain parts of the code because they're afraid that if they do, it's going to break something. And, you know, and a lot of the people that were the original developers, they probably have departed. And you know, as developers, how we all love to do documentation. And so, you know, the documentation gets out of date. And now you're having to take this whole thing and somebody's new set of people coming in, or, you know, a few other ones that worked on one section of the application. Now they're trying to say, oh my gosh, this thing has become just totally unmanageable. Prime example, I worked with our telephony many years ago. Our billing system became this huge monolith. I mean, it was enormous, and you had to look at, because we had many different ways of billing customer depending on packages they have and that type of thing. And so they thought they wanted to redo the whole thing, but a lot of people were afraid to go in and touch different aspects of it. And instead of breaking it down in smaller chunks to migrate certain pieces, they tried to take on and chew the elephant in one bite. They came quickly to realize that it was too costly to do that. So let's look at, now we want to go through the process. We're going to migrate to these microservices. We want that faster time to market. And we need to have these components that update more frequently than the others. We want to scale. The code base has gotten too big and complex. And so now we're looking for a solution. And so now how are we going to take that monolith and how are we going to go about doing it? And so one of the patterns that you'll hear Martin Fowler had talked about quite a bit, and I believe he may be the author, if you will, of the pattern, is called the strangler pattern. And is often referenced. And what you're doing here, next slide, Paul. So what you actually do is you take this huge monolith and you take a piece of that part of that monolith, and you're going to slice out a certain portion of it, you know, as a service that you're going to take it and slowly move it off out of that whole monolith. And usually what you'll do is you'll take that part of the application that people know, we're always having to change this section for whatever reason. We want to add new features to our customers. We want to, we're always seeing that, you know, potentially performance issues in that area, you know, a myriad of different things that we realize this is the piece that we want. So you come to the agreement that everybody says, this is the section we want to slice out of our monolith. So you go through that whole process. and looking at it. And so what you then do is you have this, set up this facade between your existing application, which is your monolith, and then the new service. And this facade is able to then route between knowing, depending on the transaction being executed, it knows whether you should go to the monolith or to this new service, this microservice. And then that microservice then obviously will have to communicate back with the actual monolith. And you do that over time. You do that in these a little bit at a time, creating these new services. And eventually what you're doing is you're strangling that monolith where it no longer is viable. And eventually then you actually have your whole new applications in a microservices architecture. Okay, Paul. Now, we all, we're all developers. We all love the new thing. We're all excited. Yeah, let's move to microservices. Hey, it'd be neat to say that I moved this monolith to a microservices. Boy, it's gonna look good on my resume. I like to refer to that a lot of time as a resume-driven design. But all is not for free here. There are other things that you need to consider when you move to this microservices platform. For one of those things is you're going to end up with more services, which means more network communications. With more network communications, you then might have overall increase in network latency, which then leads to a decrease in your overall performance. Just to the number of network hops and the marshaling, unmarshaling as it goes from service to service. Again, that is just something to think about. It may not be the case, but keep that in the back of your mind. And sometimes you can actually improve that performance instead of just doing HTTP calls, REST over HTTP, is use something like gRPC to actually improve that overall performance. Now, we know that with distributed systems, there will be failures. Plan for failures. That's just a given. We have them in the monoliths, and so I'm not sure why we wouldn't think that we're not going to have it in the microservices world. So plan for that. And then also make sure you build in some resiliency with circuit breakers, your timeouts, and your high availability. Those are very important, especially in the microservices world, because you're dealing with so many more systems or actually services, and you need to be able to have that resiliency that you're actually looking for. And so it really, and with high availability, you can, the scaling helps tremendously in that area. Now, as you can imagine, it can be very difficult to, as these services traverse through many microservices, your transactions go through many microservices, you can understand how it can be very difficult to find out where the actual problem is, especially if it's a logical problem, a problem in your logic. Therefore, one of the things that you need to do is find out, how am I going to do that? Now, there's things that you can do as using distributed tracing and some observability tools to help you identify those problems. That's a whole new talk in that whole realm of how do I debug my systems. In fact, there's a tweet from about 5 or 6 years ago, and the tweet was, I moved to microservices so that I can make every outage feel like a murder mystery. And it can be that way if you do not have the right tools in place. So, and then finally, you have more moving bits and pieces that you're talking about. Automation becomes harder. But what we want to focus on here is distributed transactions. This is something that a lot of us, that we really need to think about. If you read a lot of the theoretical and academia type stuff, they said, oh, build all your microservices so that you never have to have transactions. Well, that's not going to happen in the business world. It will help in it, obviously in your hello world or that stuff, but we need transactions and we need to be able to handle, to compensate when things go wrong. Okay, Paul? So let's look at, let's talk briefly about it. So there is a thing that you'll actually hear in distributed transactions around in microservices. You'll hear them as referred to as Saga patterns. This was originally written in a paper back in 1987. So it's the old thing. Things that were old are new again. If you think about, 33 years ago, this paper was written about Sagas, and now it's coming into play regarding the deployment of a microservice architecture. So what actually happens with a Saga? What is an actual Saga? So basically the Saga just means it's, maintain data consistency across services using a sequence of local transactions that are coordinated using asynchronous messaging. So instead of in the days, well, still today, the application servers, you would use a two-phase commit in the XA protocol, and then you'd end up with this transaction coordinator, and then it would maintain all the resources, and then it would eventually be able to, if there was any kind of failure, it would be able to roll back all the resources that were involved in that. Well, and microservice, especially in a large application, that does not happen. You don't have that, and there's various reasons, because you can end up in deadlock situations. So what you actually have, in the applications, you had the ACID transactions. Well, now with microservices, what we're dealing with is ACD. The isolation is really gone. And the reason that is because updates made by each of the Saga's local transactions are immediately visible to other Sagas once the local transaction commits. With the two-phase commit in the XA protocol, if there were updates to the database, the database was handling it, locking it, and they couldn't come in and see that until everything was committed. Well, because a service is doing a local transaction commit, it then becomes immediately available for other processes to come in and see the new update. Okay, Paul. And one of the things to keep in mind is what you have is eventual consistency because of those local commits. That potentially means that, hey, I could have one of my applications, let's say a table in my database, it gets updated, and then another service needs to execute and grab it and do something with that data. However, that service goes down for whatever reason, but because you're doing asynchronous messaging, you're not going to lose the message. However, for that new service, if somebody were to then eventually come in and read, as soon as that service came up and that update didn't happen, they're gonna be something out of sync, because eventually it will get updated because that message will then get processed. So you end up with this eventual consistency between your services, but there's not an issue, because there is ways to deal with this. And then it's also with distributed transactions, in the two-phase commit XA, we had things roll back. Well, and in microservices, the way you get things to roll back those changes that were updated need to be moved back, will be using compensating transactions, and Paul will go into that. Next slide, Paul. So here's some of the issues and I'm not going to go into them. There's a paper there that I posted, and obviously you'll get these slides that talks about how you deal with these lack of isolation anomalies, because you can get lost updates. In other words, one process comes in, updates, something else comes in and updates behind it. Well, that previous update potentially could have been lost because they read, let's say, pretty much the same way, same time. They get the information. one updates with a new value, the other guy comes in with a different value, and lo and behold, you end up with that the first guy, his update was actually lost. And so you have to potentially deal with that. So you end up with dirty reads. A transaction or a Saga reads the updates made by a Saga, but it has not yet completed all of its updates. And then obviously the fuzzy non-repeatable reads. So each of those, so there's several countermeasures for each of this, for this lack of isolation. You have semantic locks, commutative updates, and I'm not going to go into, because again, that's a whole new paper and we don't have time for that. And then pessimistic reread value. This is probably one of the more common ones, where even though you go in and read it, before you go and do an update, the application looks to see if the value that I have is different, or you have a indicator saying that somebody else has updated it since you read it. And if that's the case, then it will not update that record. You know, you decide then what that behavior is based in your application. And then you have version file to look to say, hey, what version is this? And then you also have the by value. But I would highly recommend that you grab this paper from ACM, and being able to deal with all these countermeasures when it comes to your distributed transactions in your microservices. Next one, Paul. And so at that, I will now turn the rest of the presentation over to Paul Parkinson. Paul?
Thank you so much, Sherwood. So another topic that Sherwood touched on is the communication across microservices. And so, of course, we have synchronous and asynchronous. And both will be used in a microservice architecture. You'll see both used, but due to the very nature of microservices, the fact that we're breaking this logic into independent services and introducing the network, you know, that's one of the biggest, if not the biggest aspect of dealing with microservices. You'll see an increase in the use of asynchronous communication. And again, as I say, you will, you know, there's not a flat rule, and you will see both. You can scale synchronous applications with horizontal scaling and things like that. But asynchronous brings a lot of advantages in the microservice world. And a lot of that's with loose coupling. You know, loose coupling of APIs is more possible. The ability to send messages even when services are down, to not have to deal with the, you know, as much of the fault tolerance and circuit breakers and things like that that you would with synchronous communication. And one of the more prevalent patterns when dealing with data in microservices, the event sourcing pattern. And that involves the sending of message whenever data is manipulated. And so a change is made in the database and you send a message to that effect, and any service that is interested in that consumes it. And so their information is sourced from events. And so we get into a number of nice aspects of that as far as being able to decouple the reads and writes along sourcing and you know, traditional writes to a database. Now, as I say, that involves manipulating data and sending a message. And so these are two actions, and if they are not atomic, you can see how on the sending side, that may be an issue if one happens and the other doesn't, and there's a system crash. The system needs to rectify where it was as far as if it sent the message or not. And then also on the receiving side, because again, because if the data was written but the message not sent, or vice versa, the application now has to deal with these issues, such as you know, as I say, rectifying the messages sent or handling duplicate delivery of messages. And so again, they say, as Sherwood was saying, you know, a lot of people say don't use data in your microservices, or make sure your microservices are programmed to be idempotent. And of course, that's easier said than done in the real world. So especially if you're bringing an application from a monolith that isn't expected to be called twice, that becomes an issue. And so one of the nice things that we have in Helidon is an integration with the Oracle database and its AQ functionality, where you can actually do this writing of data and sending of an event in the same transaction. So you get the benefit where you don't have to write extra recovery code, as all the details Sherwood was just talking about, to handle redundant duplicate messages. Now let's take a look at a bit of the landscape to see where these different products and frameworks lie. So we're going from large to small, top to bottom here. So at the top, you have your monoliths, your mainframe to your application server, and then you're moving down to things like full stack like Spring Boot and Drop Wizard, which are still very large footprint, not the fastest startup time. Then you're moving down to smaller frameworks such as those that are micro-profile based. And if you're not familiar with micro-profile, if you are familiar with Java EE, micro-profile is essentially Java EE tailored for microservices. And so the Helidon MP implementation is an implementation of this micro-profile, provides implementations of the specifications there. And then you move to even smaller micro frameworks, extremely small footprint, but not necessarily micro-profile implementations. And so in Oracle, we decided to have two versions of Helidon, one for this SE, for this more micro-profile, micro-framework style rather. And a lot of the difference between SE and MP is really just that, the kind of programming style. In Helidon SE, you have this more functional reactive style. It's transparent, and by that we mean, basically what you code is what you get. You're not using a lot of CDI as far as annotations and things like that. Whereas Helidon MP, as I say, is an implementation of the micro-profile standard. And so this is very familiar to Java EE developers. It's a very natural migration using all the similar or same annotations that you would find in the Java EE world. And then both have support for GraalVM, if you're familiar with that, and a number of DB and messaging features, as well as extended Saga features. So we make sure with Helidon, not only that it's very performant and developer friendly, but of course we are focused on integrating with OCI and the Oracle database and making the best solutions overall. And so our biggest focus, my biggest focus, is simplifying exactly the problems that Sherwood just mentioned. And so, as I just mentioned, we have integration as far as messaging with the database, so that your events and your messages are in the same transaction and things like that. And then we also have building integration as far as the Sagas for some of the read considerations. So we're working in cooperation with the database for escrow locking, which is operation locking for hotspots to deal with some of these isolation issues, and auto-compensating data types in the database so that you don't necessarily need to write your own compensation methods, and the database will handle that for you. And that's a very error-prone area. So that's a huge advantage. So I'm just giving here a few examples of annotations related to data, but also related to microservices in general. But very necessary for when you're dealing with data in distributed transactions. So tracing, metrics, health, messaging, as I mentioned, and some of the LRA. And so now some people may be wondering, what does LRA stand for and what is it? So LRA stands for long-running actions, and basically it's almost synonymous with Sagas. So it's the micro-profile specification for dealing with Sagas. So if you're familiar with Java EE, LRA is very similar to JTA. And what you see here are annotations for demarcating and controlling your Saga, for controlling your long-running action. And so the first, I'm not going to go into these in too much detail, but to give you an idea, the first annotation is the LRA annotation, and that's like the transaction annotation in JTA. So you put this on your REST endpoints, or in the case of Helidon, if you're using messaging, on your messaging endpoint, and you give it a transaction attribute, an LRA attribute, and this is the exact same set of values as in JTA. So we'll see in an example, requires new will start a transaction, mandatory will ensure that you're in a transaction when you execute your method, things like that. What is unique, what is different from JTA to LRA are these compensate and complete methods. So if something goes wrong in your LRA Saga, the LRA coordinator, and we'll look at the architecture a little more in a second, will call this compensate method if in failure cases and the complete method in success cases. And then really quickly, the coordinator will call forget on participants that that can be allowed to forget about the Saga, and a participant can indicate it wants to leave a Saga with this leave annotation. And finally, the status annotation is for the case where the coordinator has called complete or called compensate, but did not get a response back or an ambiguous response back. And so the coordinator will call status to find out what the status is of that participant. And again, if we're using transactional messaging, the status method becomes something that's not actually really necessary. So it's an advantage of messaging and the Oracle database in particular. So here's an example of those annotations I mentioned. So this is and I'm going to go through a sequence flow and return to this, but I want to show it very quickly up front. This is a Saga or LRA using a travel booking scenario. So in this case, the travel agency is called and attempts to reserve a flight and a hotel. And if both are successful, it returns okay. If either fails, it returns an error. Okay, just obviously this is very pseudo succinct code here. So when it calls the flight or hotel service, which are basically the same, the LRA annotation here is mandatory. So up here, the LRA annotation was requires new, which started an LRA Saga. And then when this travel agency called the flight and hotel service, their method was annotated with mandatory, meaning it has to be invoked in this Saga. And then if it's successful, it returns successful. If not, it doesn't, it returns fail. And then this compensate or complete method will be called depending on if it succeeded or failed. So let's just walk through that again in a little more detail. So we have the application calling the travel agency. Because of that annotation, behind the scenes, the LRA library or client, whatever you want to call it, that is resides with the microservice, behind the scenes calls the coordinator and enlists that travel agency. It starts the LRA Saga. The travel agency then makes an application call to the hotel service to reserve the hotel, and the LRA library on this service calls the Helidon coordinator to join the Saga or LRA and returns, and the response is returned to the travel agency. And then the same thing for any other participants. And this can happen in parallel. We then get the response from the services and determine if the hotel and flight were booked successfully or if they were not. And in reaction to that, we will call either implicitly or explicitly from the travel agency to the coordinator to tell it that the Saga should complete or compensate. And in reaction to that, the coordinator goes ahead and issues the corresponding complete or compensate calls on the participant, and then returns to the travel agency, which then can return to the customer, to the user. So again, let's just return to those annotations to look. So we saw that it came in, started a transaction in the book travel here. It then called these services and listed, and then we saw the compensate or complete called for that case. So I'll just show you very quickly in a demo the same concept. So in this demo, we have the exact same flow. We're just using an order and an inventory service. And here, if I add an inventory, I can see the inventory count is 1. And so when I go ahead and place an order, what will happen is the order service will start the LRA Saga, and it will call the inventory service to check whether there is enough inventory for that order. The inventory service will return, success or fail, depending on whether it has inventory. In this case, it does. And then the order service will call the LRA coordinator and tell it to either complete or commit. And then we will see the corresponding methods that have been annotated with compensate, or complete are called. So let's go ahead and place that order. And you can see the order service receiving it. It called the inventory service, which gave back a success. We can see our LRA ID here with the location of the coordinator. And because of the success, the order service calls complete on the LRA coordinator, and then the LRA coordinator calls complete on order and inventory. And so we see in inventory, the complete orders for things like cleanup, or as I have here, prepare for shipping, because the order and the inventory were successful in this case. So then let's go ahead and just do the compensate case. We will remove the inventory. So we see the inventory count as 0. And then we'll go ahead and place the order. And we see that it's failed as expected. And that's because the order service called and got an inventory failure case. And because of that, the LRA coordinator called cancel on the 2 participants, cancel on order and cancel on inventory. So put back the inventory. The compensating activity is in that method. So just a very quick, example of what I'm talking about here. So that was fairly simple. Now we're kind of moving into more complex scenarios in the real world. So Sagas have actually 2 different types. One is a choreography. If we go back to our scenario here, a choreography involves a saga between services that work out the actual Saga activity and compensation themselves. So in short, it does not have a coordinator or orchestrator. If the hotel and flight service worked out the coordination between themselves without this coordinator, that would be what's called a choreography Saga. What we are looking at with LRA is called an orchestration model for Saga, where you have a devoted service, which can be co-located with other services that coordinate the Saga. And so that is what the LRA specification and implementation is about. But for more complex flows, you might move to a workflow engine such as Camunda or Oracle Process Manager. And so that's what we see here, the same idea. You have compensating methods for an activity which involves many participants and a complicated workflow. And then as you get into even larger architectures, this is something Sherwood and I have worked on, that where we have, again, as he mentioned, this can be a hybrid world where we have WebLogic sending a message over Kafka or over AQ Kafka. And then we have an LRA Saga conducted here, but one of the LRA Saga participants is actually a Camunda workflow. And so you can see how this is a bridging factor that we're using this LRA for here. And so, a number of concepts here as far as orchestration and compensating activities. And again, we have a lot of integration with the Oracle products for this. So those are the topics I wanted to talk about. I also wanted to draw your attention to a workshop that has a number of these different data, microservice data concepts. And I'm in the process of adding an LRA example to this as well, but it's a very robust lab where you can set up ATP, your OKE, Kubernetes clusters and things like that in very short order, and go through a lot of these concepts. And like I say, I'll be adding a number of the things that Sherwood and I have been working on to this. And with that, I'd like to thank you and open it up to any questions you guys might have for us.
Hi, and there is an open question from Sean, develop. How far in the coordinator are managed? Should every service consider this scenario?
I'm sorry, can you repeat that one time?
Yeah, can you see the question and answer pane?
Oh, okay, I see. Okay,
You
let me,
need-
how failures in the coordinator are managed. Should service, oh, okay, yes. So this, as far as HA, that's, you know, a good question. A lot of the failures in the coordinator you will manage in an HA fashion, you know, not too dissimilar from what you did with the transaction manager. But in Kubernetes, this becomes, you know, we can provide even more of a resilience solution, because if that coordinator goes down, you know, we bring it up in another area, whatever, another region, whatever the case may be. So the routing of requests across the network is automatically, you know, aligned to wherever that coordinator may have landed. And so every service doesn't really need to consider it per se, but that is, you know, the architecture that's required.
And the other thing to keep in mind is that these, for the most part, these are not request response, you know, synchronous type. When you're doing this, especially with a large number of services, they're going to be asynchronous. So if, you know, if everything died, you would still have the message and then it would pick it up when it resumed, you know. And so that's one of those things that you have to keep in mind with the eventual consistency, is that, you know, it went down and so it didn't get to process the message that, hey, I did an update or you need to update. Something else comes in and reads it. But eventually it will get there. And so, you know, all of this like that we're doing here that Paul had showed at the last slide there, from the monolith, which is WebLogic, over to Camunda, and even inside Camunda, it's all done through messaging. And so that we can always make sure if something dies that we can always still process it, that message. Now, obviously you need to decide in your application, if it does die, hey, I wasn't able to get it picked up or whatever, however you want to do it. Do I then say, let's compensate the transaction, put the message back at the beginning and, you know, clean up everything else through the compensation process? Or do I allow it when it comes back up to pick up the message and continue processing? So you need to, you know, think about that. You have to take a little more thought into your application when it comes to transactions between these distributed services. Hopefully that answered the question.
Ok. Bueno, gracias a todos por... sí, yes. Gracias a todos por habernos acompañado en este webinar. Les recordamos que pueden seguir participando del evento, registrándose a las sesiones que quedan todavía. And thank you, Sherwood and Paul. We really appreciate your support. This was a great session. Thank you for all.
Great. Yes. Thank you so much.
Thank you, everyone.
Yeah. Feel free to reach out with any other questions you may have.
Yeah, and then like we said, we will be putting out the whole big full scale with all the messaging and using the orchestration engine and all that stuff. So be look for that probably in a few weeks with the whole write-up and everything soup to nuts on how we did it.
Great. Many thanks.
Okay?
Okay.